Okay, I took a break because I had to make some room. It was full. Okay. Uh, okay, and this is some notes I added in the middle of the night. Okay. And This is continuation. This is from page 13, though I skipped some stuff. This is from the latest article. It's to be added to 794 Proof of God from 2017, and also continued. I think it was in August 2024 that I did another hour on proof of free will. Okay, so this is continue. It was based on Kant, so this is also mostly on Kant. So I'll add that. Okay, so add this. Okay. In the first critique, Kant argued that a fallacy in the syllogism used in the Antimonies of Cosmology, really also a fallacy in the paralogisms of psychology. Really, Antimonies of Cosmology and the paralogisms of psychology. Really, the faculty of the understanding uses these syllogisms, but it does not mean that it always engages in fallacies. In the Antimonies, the problem was that it was not clear if the series and the major premise was finite or not, but you can have syllogisms where the series is finite. For example, if A then B, A, therefore B. Oh, by the way, I found an essay I wrote at McGill University in 1985 about Kant, and I saw that in that essay I wrote that the the dialectic was divided, and the psychology of paralogisms I said was based on the categorical syllogism of Aristotle, and uh, the Antimonies of Cosmology was based on the hypothetical syllogism of Aristotle, and the ideal was based on the disjunctive syllogism of Aristotle. Uh, that's also important. Kant argued that the law of causality applied to the faculty of understanding, since the transcendental analytic showed that perceptions enter space and time in our mind, and is the categories that causal is the categories like causality which allows us to organize it into a unified experience. Also, the transcendental dialectic shows that you can get antimonies, but these antimonies were resolved since it is the causal series was seen as in time, then the syllogism used must be invalid, since the unconditioned may not be given. It is only in logic that the premises may be outside time and reach the conclusion. Um, Really, another thing is that for Kant, we did not know if space and time exist in the world. But since if we accept Einstein, who argued that space and time exist in the world, then Kant had the Copernican revolution, but he had to argue that space and time existed in the mind. So the law of causality cannot be broken. But if so, you can organize perceptions into experience. But if Einstein is right and space and time exist in the world as defined by the speed of light, then uh, then the world will be organized already. So when it comes to our mind, we don't have it doesn't we don't need the law of causality inside our mind in a sense to organize it, because these perceptions come to us organized already, because for Kant they were not in space time in the world, but if they are in space and time in the world, then they're already organized. So when they come to our mind, they're organized. So yeah, we can see them. We don't have to you. I mean, they're already organized. That might be important also. Way can another way to put together Einstein and Kant's philosophy. Okay, so the faculty of reason failed in its goal to reach the unconditioned, since it required the law of causality, but Kant argued that the law was in time and hence belonged to the faculty of understanding. It was necessary to introduce it to unify all possible experience. This was the third antinomy of freedom as well as the other antinomies. Maybe we must add a step. Really, the problem of the common syllogism to all the antinomies was that if the series is in time, we do not know if it will terminate or not. Aristotle argued that it is finite or must terminate, since an infinite magnitude is impossible unless terms in the series uh, vanish, so does not become an infinite magnitude, because an infinite magnitude was impossible. I think Averroes said that magnitude is even or odd, so therefore infinite magnitude is impossible, because infinity is neither even nor odd. That could be begging of the question anyway. But Cantor, I recently saw 2 lectures on Cantor, but Cantor argued against Aristotle and Gauss that you can have an actual infinite, not only a potential infinite. So maybe there are some series that terminate in the unconditioned, since they can be finite, and even some infinite series, Cantor may argue, are completed. So you can use these series. So if the series of causes in the argument is outside time, it must end. And if it is in time, then Cantor still argues that some series are infinite but completed or actual. Really, there are also tests in the mathematical calculus to determine if a series is convergent or then stops, or if it is divergent and goes on forever. And Taylor's theorem converts a function into an infinite series, also a Fourier method, and, and, and converts function to an infinite series, and moment generating functions in combinatorics and probability theory, which convert an infinite series to a function. Uh, well, I think in calculus you have the integral test, and uh, so you have other values. You take the, I think you, the n term of the n plus one term, etc. And you can in calculus you consider uh, infinite series. You also consider sequences. You see, even found out later that you can consider even infinite products. And you also have series which is alternating positive, add, subtract, add, subtract. Yeah. But keep in mind that Kant argued that space and time are pure a priori intuitions and can only be, and he only argued that the law of causality cannot be broken so that we can organize our perceptions. This is part of his Copernican revolution, since he argued we cannot know objects, but we can know how objects appear to us. But Einstein argued that we can know the external world, as I just said. Einstein's theory of relativity is only an approximation, but true inside our minds. Then, if that is so, then there there in our mind space is non-Euclidean, since light speed is invariant in our mind. The the brain generates light, and it goes where we go. If in the world light speed may not be invariant, but depend on the speed of the observer or the source. Some professors think ideas like non-Euclidean geometry proved Kant wrong, On the contrary, if true, it proves that he was right about our limited knowledge of the nature of space and time outside in the world. Also, we know that the causal series outside time may be broken and reach their condition. Did Kant completely reverse his approach here? Question mark. In the first critique, he tried to prove we are free by examining the series of appearances coming to us from the world, assuming that other people have a mind similar to our own, and going up to the faculty of reason. In the second critique, he tried to prove free will exists by starting from our faculty of reason and going the other way, and the moral code, and it's going and it's considering its power in the world. For Kant, you can have maxims which are subjective laws, but practical laws are objective. They are necessary and universal, hence, for every rational being. The moral law is not empirical. Really, you have to keep in mind that Kant's theoretical philosophy, he argues that things and events in the world could not be known, at least not with certainty and universality. And in the second critique, he says that reason must act through, though it is not clear how, since it must have knowledge of the events in the world, and it does not have that.